Okay, so this is day 2 of notes for hyperbolas. So first we're going to start by just going over the 3 equations we've learned so far, just so that we know the similarities, differences, and we make sure that we remember them. So remember the equation of a circle. You have x minus h squared plus y minus k squared is equal to r squared. Okay. For an ellipse, I'm going to show you the 2 different equations technically that we've gone over so far. So you could have x minus h squared over a squared plus y minus k squared over b squared equals 1, right? Or the difference we could have, it's still x minus h squared, but the b could be on the bottom first here. Plus, and then y minus k squared over a squared equals 1. Remember that for ellipses, a is always the bigger number, so it could be with the x, it could be with the y. Whichever it is under tells us whether it's going to be a horizontal or a vertical ellipse. And then hyperbolas, which is what we went over a couple days ago. Again, you have 2 options here. You could have the x minus h squared over the a squared minus, okay, big difference here, it's always minus. So then y minus k squared over b squared equals 1. Or remember, now it's the x and the y that can switch. So now it could be the y that comes first. With this, a is always first. Okay. All right, so then now you kind of have that at the top of your notes all in one place here so you know the difference. First couple are going to be mostly review. We are adding in domain and range here. So here's our equation. Our center is at 0, 0. You're not adding or subtracting anything to the x's or the y's. To graph this thing, I'm going to look first under the x's. That tells me left and right. Take the square root. That gives me 9. So I'm going to be going left and right 9 units here. Look under the y's to tell me up or down. Take the square root. That gives me 6. So I'm going to go up and down 6 units. Okay, from here I'm going to draw my rectangle. Do my best here to draw in my asymptotes. And then I go back, since the y's are first, I know it's going to be opening up and down. So I can go ahead and draw in the hyperbola. So my vertices here, remember, are the 2 points that are actually on the graph of the hyperbola. It looks like I went up and down 6 units. So 0, 6, and 0, negative 6. Okay, for the foci, I'm going to use my equation here, a squared plus b squared equals c squared. So 36 plus 81 equals c squared. That cannot be simplified, so root 117. So again, it's the y value that's going to be changing. It's at 0, so I'm just adding and subtracting that root. So 0, positive root 117, 0, negative root 117. Now, for the domain and range, we haven't really talked about this yet. Remember, for domain, you think left and right. So in both of these pieces, actually, the graph does go left forever and it does go right forever, and there's nothing that's going to be, there's no holes, there's no skips. So this domain is going to be negative infinity to positive infinity. Okay, it does go left and right forever. For the range, though, you want to think up and down, right? So if you kind of look at this piece, the bottom piece, it does go down forever. Okay, if you look up here, it does go up forever, but there's this space here where there is no red, right? There is no part of the graph in that space. So when I'm naming the range, I'm going to start at negative infinity because it does go down forever. But then for this bottom piece here, I want to see, well, where does it stop? So it looks like it stops right here at the vertex, which is at -6. I'm going to put a closed bracket because it does actually touch at that point. Okay. Remember, then I put that U thing to show that there's a gap, there's space. It doesn't start again until this vertex, which is at +6, and then it goes up forever. So I'm going to finish with positive infinity there. Okay, good. One more of these. So this one, the center's not at the origin, so we have to be careful here. Center, so I look at my x value first, so center is going to be at +2 and then -1. So I can put my center there. We look under the x's. Okay, that tells me left and right. Take the square root. So I'm going to go left and right 5 and then up and down 2. Okay, so I can use that to draw my rectangle now. Draw the asymptotes. And then, since the x is first, I know it's going to be opening left and right. So I can go back in and actually draw the hyperbola. Again, approaching those asymptotes. Okay, so these 2 points that I use, those are my vertices. So again, I can kind of just see where they are on the graph. It looks like it's at -3, -1, and 7, 1. Or sorry, 7, -1. Okay, I need to do a squared plus b squared equals c squared. So 29. Okay, so that can't be simplified, so c is equal to square root of 29. So remember, it's my x value that's going to be changing from the center. I can tell that because the x is coming first here in my equation. So I need to take the value, which is 2, and then add and subtract that root 29. So I'll do 2 minus root 29, keep the y value of -1, and then do 2 plus root 29, keep the y value of -1. So here, domain and range are going to be a little different. So for the domain, you want to think left and right. So if we look at the graph here, this time the graph is going left and right forever. Okay, this piece it goes left forever, this piece it goes right forever. But again, there's going to be this gap here where we don't have anything. So for the domain, it starts at -infinity because it goes left forever, and then you need to figure out, you know, it goes up until what point. So the vertex right here is at -3. Okay, then we put the u. We figure out the new starting point, which was this vertex over here at 7. And then it does go right forever to positive infinity. For the range, you think down and up forever. For both of these pieces, it does technically go down forever, even though it, you know, it's not going down very fast. It does go down forever. It does go up forever, and there is no jumps or gaps when you're looking down to up. So the range this time is negative to positive infinity. Okay, so for the rest of the problems, we're going to be practicing how to write the equation based on information that they give us. So, find the equation of the hyperbola that has x-intercepts at ±6 and foci at -10, 0 and +10, 0. If it helps you to draw just a rough sketch, you can go ahead and do that. So, the x-intercepts, it says it's at ±6. X-intercepts is where the graph crosses the x-axis. So at here, you know, this would be at +6, that's at -6. Which all that's telling us is that it touches the graph there. What's really helpful is this part. The foci are at -10, 0. So I can draw those as little stars, right? +10, 0. This is helpful because it tells us that the x-axis now is the major axis, and the hyperbola the vertices are also on that axis. So you know it's going to look something like this. It goes through the vertices around the foci. Okay, so it also tells us that the center is at 0, 0, which is helpful. So because it opens left and right, that tells us that in our equation, x is going to come first. And because it's centered at the origin, I don't have to worry about adding or subtracting anything to the x's. So I'll have x squared over something, remember it's minus, and then y squared over something equals 1. So I need to figure out what's going to go under the x squared and the y squared. Now, I already know that from the center, I'm going left and right 6 units for my vertices. So I know that under the x, there's going to be a 6 squared. What I don't know is how far up and down I would go to make my rectangle. Okay, so I'm going to have to use my equation a squared plus b squared equals c squared. So I know that with hyperbolas, a always comes first. So I know this is going to be 6 squared. I don't know what b squared is, but I do know that c is the distance from the center to the focus, which would be 10. So I can plug in 10 and then squared here to solve this equation. So 36 plus b squared equals 100. Subtract the 36. So b squared equals 64. And so b is equal to 8. So back in my equation, I know that b is 8. Remember, it's always squared here. So my final equation is x squared over 36 minus y squared over 64 is equal to 1. Okay, so anytime they give you or they mention the focus or the foci, that's a hint that they're telling you the value of c and that you'll have to use your equation to find the value of a or b. Second one is not too bad. It's pretty similar here. Find the equation of the hyperbola that has y-intercepts at plus or minus 5 and foci at 0, 6, 0, negative 6. So yeah, it's pretty similar. They tell us that the vertices here, or no, sorry, they tell us that the y-intercepts are at 5 and negative 5. Again, that's just where it crosses the y-axis. What's helpful is that the foci are at 0, 6 and 0, negative 6. So yeah, that tells us that it's going to open up around the foci and that these have to be the vertices. It also tells us again that the center is going to be at 0, 0. So this time, since it opens up and down, it's going to be y squared over some number minus x squared over something equals 1. Okay. How far up and down did we go to find the vertices? That was 5 units. That's going to be under the y, so I put 5 squared. And then again, these foci at 0, 6, 0, negative 6 is telling me that c is equal to 6. So I'm going to want to use my equation once again to solve for b here. So I'll have a squared plus b squared equals c squared. So 5 squared plus b squared equals 6 squared. Whoop, didn't plug in 6 here. So 36, subtract. So I get b squared equals 11. Okay, so b is equal to the square root of 11. So when I go to plug that back in here, remember it'd be root 11, but I'm squaring it, okay, because it has to be b squared. So my equation, y squared over 25 minus x squared over 11 equals 1. Okay, and then the last type, which we've done with circles, we did it with ellipses. It's going to be completing the square, but this time it's going to be with hyperbolas. Okay, the strategy is pretty much the same. You want to group the x's, group the y's. Remember that when you're done and you have your final equation, it needs to be something minus something else. So that's kind of a clue. You know, this is a positive x squared and a negative y squared. So I'm going to keep the order how it is right now, hoping that it stays that way. So then the x's, it'll be the x's minus the y's. Okay, so you remember that you take out your GCF. So for the x's, I'm going to take out a 10. That leaves me with x squared plus 6x plus blank. Here I'm going to take out the negative y. I will always want to take the negative out with it. So that will leave me with y squared plus 2y plus blank equals, and then I'm going to add this 9 over, so I get a positive 9 over here. Okay. So then I'm going to go ahead and do the b over 2 squared. So 6 over 2 squared here. So 3 squared is 9. That goes in the blank. Remember that I need to multiply. 9 times 10 is 90, and that's what I will add to the right side. Okay, same thing over here, b over 2 squared. So 2 over 2 squared is 1 squared, which is 1. Be careful, because this is really a negative 9 times a 1. So over here, I need to do minus 9. And then I can go ahead and rewrite this thing. So I have the 10 out in front. This will be x plus 3 squared. Remember, I used that value right there, the number that's being squared. Okay, that's what goes here. Minus, I have the 9, and then a y plus 1 squared equals, these just cancel out, so I get 90. So then my last step, divide by 90 so that it's equal to 1. Okay. So when I simplify here, I'll get x plus 3 squared over 9 minus y plus 1 squared over 10 equals 1. And there is my hyperbola. All right. Last one like this. Okay, so with this one, I noticed that the x squared is negative. You can either leave it like this and then switch it at the very end, or you can switch it now, hoping that it will stay like this and you won't have to switch it again. It's really up to you. The issue is that, you know, when you're done over here, if you have to divide by a negative, you're going to have to switch your stuff on the left-hand side. So it's really up to you if you want to switch it now or later. I'll go ahead and switch it now. So all I mean by that is I'm going to write the y's first, and then I'm going to write the x's. So I'm going to start with the y's. I'm going to take out that 36 and move that out in front. So I'll have y squared plus 4y plus blank. Here I'm just going to take out a negative 1 for the x's. So I'll have the negative 1, and then I'll have x squared plus 10x plus blank, and then equals the negative 115 that's already over there. Okay, so do the b over 2 squared. So 4 over 2 squared is 2 squared, which is 4. So I put the 4 there. 4 times 36 is 144, and it's positive, so I'm going to be adding that to the right side. Okay, over here I have 10 over 2 squared, so 5 squared is 25, so that goes in the blank. And then again, when I multiply, careful, it's going to be negative, so minus 25 right there. Okay, so when I rewrite this, I get 36, and then I have y plus 2 squared minus a 1, and then x plus 5 squared equals, so when you add all this together, you should just get 4. Okay, so my last step here is to divide by 4. All right, so now this is a little tricky. I don't think we've had this show up yet. You have 36 over 4, which is really like would be left with a 9 on top and a 1 on the bottom. And I'll show you how to deal with that in a second. I'm just going to finish writing the rest of it. The 1 here can go away, so I have x plus 5 squared over 4 equals 1. Now, the 9 out in front, technically you could leave it like this, but it's not really helpful when you would go to graph it because you don't know how far In this case, up or down you'd be going. So we're just going to rearrange this. A different way of writing this, and I'm going to write it on the right-hand side here, would be to just move this 9 into the bottom of a fraction in the denominator. Okay? It's the same exact thing. You're not changing the problem in any way. You're just moving it, rewriting it, so that now it would be easier to see how far up and down you would go to graph it. So the final equation here is going to be y plus 2 squared over 1/9 minus x plus 5 squared over 4 equals 1. Okay, so if you ever end up with a number still on top of your fraction, you just want to go ahead and move it into the denominator of your fraction, right? Move it into the bottom, and then that way, you know, it would be easier to graph. Yeah, and that's it. So your homework, last homework for this week, is that Hyperbolas Day 2 worksheet. Again, please email me. Let me know if you have any questions. All right, thanks, guys.